So according to this question, a human factors experiment expert, that's what it said. I was reading that wrong. A human factors expert recommends that, yeah, that's so weird. I don't know what a human factors expert is, but recommends that there be at least 9 square feet of floor. Yeah, Mariam, you got it. Good job. Space in a college classroom for every student in the class. Find the minimum floor space that 17 students require. Yeah, Mariam is right. All you're really doing here, this is a proportion question, but do you have to set up a proportion to solve this? No, you certainly don't. Yeah, you don't. You're right. All you gotta, we gotta think it through, okay? 9 square feet, so it's always good to kind of highlight relevant information. 9 square feet of floor space for every student. Okay, that's the first piece of information that kind of jumps out at me. So that's 9 square feet per every student. And this is different than that changing dimensions thing because we're not comparing the areas together. We're not doing that. We're comparing square footage per student. That's kind of what we're doing. And then we want to set up a proportion, or when 2 ratios are equal, and we're going to do the same thing. We want to find the square footage for 17 students. Okay. And what is that method that we use to solve proportions? You guys remember? What's that called? Some type of multiplication. Starts with a C. Yeah, very good, Malia. It is, excuse me, my allergies are getting me today. It is cross multiplication. So what we would do is we multiply the numbers across from each other, and you actually divide by what's left over, but in this case, you're just dividing by 1. So we would go 9 times 17 is 153. Then you divide by 1, and that still gives you 153 square feet. Okay? Good stuff. So setting up a proportion is really helpful to tackling lots and lots of math problems. All you got to do is find 2 things to compare, and then the same labels go on top. So if you have square feet, that's got to go on top, or both on the bottom. They just have to match, and then students go with students. Cool. Any questions? Oops. What? Where'd my stuff go? Oh my gosh, guys, I put that stuff in the wrong place. I apologize. Okay. Wow, that's special. I gotta fix that. All right, so it is week 13. Yeah, we've got 3 assignments to do this week, and you got it. There's a lot of formulas, pretty formula heavy. Before we get rocking and rolling, let's just do a quick check-in to make sure who's back and who's ready to go. So if you could click on your participant list and click on yes, then I know you're here. Click on participant list and then yes. Saying, yes, I'm here, I'm here. Who is here? Yay! I am still, oh, I can hit yes. Then I'm waiting on 3 individuals. Maybe 4. Let's see. 1, 2, 3. Nope, it's 3. Yeah. 3 peoples. That would be Taylor, Henry, Isabel. If you can, either put it in chat, just let me know you're here. Or click on that list. Thanks, Isabel. Henry and Taylor. Henry and Taylor. Hello. Hello, hello, friends. Hello, Henry, Taylor. I'm going to keep singing your name. No problem. Okay, no problem. Thanks for letting me know. I'm just having you click on the participant list and hit yes to indicate that you are here and you're ready to rock. Yeah. No problem. Thank you for responding. All right. Well, we're not 14 strong yet, but that is okay. I think I will still count that really well. Yeah, so you guys have 3 assignments this week. You have volume of prisms, volume of pyramids, cylinders and cones, and then surface area of prisms and cylinders. So not too bad. Just 2 formulas. 2 formulas. So you guys gotta make sure you write the formulas down today. Okay? Okay. First thing we're gonna talk about is volume. Volume. The formula for volume is the area of the base times the height. That's all you're doing. Area of the base times the height. What is volume? We have the definition up there, but does anybody have a better way of wording it? What does that mean? What is volume? Ugh, and I'm sorry, guys. Think about what volume is, maybe a good way to explain it. I just gotta, someone scheduled some awesome time with me and I want to put it in my calendar so I don't forget. Because that's not good. And that can happen. Okay. So you're thinking about a better way to explain volume. What is it? What do we mean when we say the volume of something? That's huge for my daughter right now. Yeah, there you go. The space inside an object. Yeah, that's good. Amount of space an object takes up, the space inside a 3D shape. Yeah, exactly. We're talking about volume. Okay, so yeah, the amount of space inside of a 3D figure. Exactly correct. And it's kind of nice. I really, really like dealing with volume because it's a formula. That's all. Now, what's tricky is you got to figure out what the base is, what shape the base is. So, guys, it's not too bad with a prism. Literally, for a prism, all we're doing, who left me? Who did it? Oh, Isabel was having issues. Is that Isabel? Nope, Isabel's still here. I don't know. Meaning issues with the internet, not issues. So, okay. So take a look at a prism here. When you find the volume of a prism, seriously, all you're doing is you're taking whatever 3 measurements they give you and just multiplying them together. Does not matter the order. Just get them multiplied. Okay, so you might have found that last week with your assignment. I believe you had to find the volume. Let's check that. I'll keep it on sharing. Let's check that. Let's do it, guys. Let's be real purposeful. There. And that would have been week 12. Yeah, no, you guys didn't have to deal with any volumes. Oh, prisms. Ugh, silly me. That's this week. So guys, we have like, let me just pull up a prism question. Yeah, you're just gonna plug it in. That's seriously all that you're doing. Volume of prisms and cylinders. Now these assignments here, guys, homework and test manager. These assignments, you're gonna have to really check that name and make sure you're doing the right thing. No, I don't want to edit. Ugh, guys, I'm having issues today. Oh, leave. There's all these creepy people outside my window. Volume of prisms and cylinders. We're gonna go to preview. That's what we want to go to. Give me a prism. Don't care about that. Don't care about that. It's a good volume question. Okay, here we go. Guys, we have a prism. Okay. We have a prism. All we're going to do to find the volume of this prism, the actual formula tells me to take the area of the base, so that's big B, that's area of the base, times the height. But because we have a prism, and the formula for the area of the base is just length times width, all you're going to do is multiply those numbers together in any order. I don't even have to worry about what's my length, what's my width. All I'm going to do is take those 3 numbers and multiply them together. What do we get? What is 4 times 11.5 times 7? 322 centimeters cubed. Let's see if they're right. And remember, volume is cubed. Very good. Yeah, fantastic. Thanks, Math Excel. Okay. So that's what's really cool with prisms, is that all you're doing is you're multiplying all of the numbers together in any order. Now, what's tricky with this next figure here, what is this next figure called? What is that? Friends and neighbors, what is it? Oh, pardon my yawn. That is a triangular prism, right? Triangular prism. So listen to the word triangle in there. That tells us that the shape of the base is going to be what figure? A triangle, right? Hello. No problem. This is exciting stuff. I totally get it. So the reason that we asked that question is because our formula is area of the base, so big B, times the height of the figure. So you have to know what shape you're looking for the base. It's really easy to say one of these is the base, especially if this is turned on its side. Okay, so the base isn't necessarily what what the figure is resting on. Okay, so this figure right now is resting on a rectangle. That does not mean the rectangle is the base. The triangle is the base. So we're going to take 1/2 times the base times the height, that's the area of the base, times the length of the triangle, or the height. Okay? And then for a cylinder, it's the same thing. For a cylinder, what shape is that base? It's a circle. Yeah, so that formula is the circle area, pi r squared, times the height of my cylinder. Okay, so let's do this. We want to find the volume of the figures. Okay, so the volume of this figure is going to be, we're going to first do base times height divided by 2. That's how you find the area. That's the area of my base. And then we're going to multiply by the height of the figure. So let's focus on the triangles here. Okay, there's one of my triangles. I have to take base times height divided by 2. What am I going to multiply together in there? What's the base of my triangular base? What's that value? What number? What number stands for the base of that triangle base? Excuse my yawn. So guys, take a look at our triangle here. It looks like we have quite a few numbers associated with it. We have a 5, we have a 1.5, and a 4, and a 2. And yeah, Malia, you totally got it. Very, very good. So the 5 is going to be the length of my base. That's my base. What's the height? What's the height of my triangular base? 1.5. Very good. The height goes from the base all the way to my vertex. It's the straight up and down height. So the height is 1.5, and then we divide by 2. What do we do with these other values on the triangle, the 4 and the 2? What do we do with that? Do we need those? No, we don't need them. You're right. Don't need them. Get out of here. We're done. We're good. Okay. So we've got 1.5 as our height. Our base is 5, and then we divide by 2. And then we got to multiply by the height of my 3D figure. What is the height of my 3D figure? What value is that 3D shape? Kind of takes your base and rises it up and makes it 3D. I like the 1.5. That does raise up our bottom, the base there. Okay, the 1.5 is on the base, so that wouldn't make it our 3D shape. Look at this 4 here. The 4 is what's between the two bases and gives it that 3D-ness. So whenever you're looking for a height, you're looking for whatever turns it into a 3D figure. So 4 would be my height. Good. And then from there, we could just type it right into Desmos. That's all you got to do. Oh, I don't want to hit clear. So we can go to Desmos. Highly recommend it. Makes life pretty easy there. Desmos for all your calculator needs, right? Okay, so we're going to type in, and we're going to use parentheses. So 5 times 1.5. And then on the bottom, we'll have 2 times 4. Thank you, Sam. And we got 15. So the volume of this figure, we would say, is 15 yards cubed, cubic yards there. 15. Questions on that? Any questions? Does that make sense? Please type yes or no. Does that make sense? And you might just need to wrestle with it a little bit. Okay. All right, good. Good, good. Okay, let's talk cylinder here. Cylinder is the same deal. It's going to be volume is the area of the base times the height. And when we find the area of the base in a cylinder, it's a circle base. So it's r squared times pi times that height. And remember, they might ask for an exact answer and a rounded answer. Which one has pi in it? Is that the exact answer or the rounded answer? Which one has pi in it? Yeah, the exact answer has pi. You're right. So let's talk about this one, friends and neighbors there. What is my radius? What am I going to put in there for my radius? I know pi stays the same. What's my radius? 7. Yep. 7 is my radius. So I'm going to go 7 squared times pi. And then what is that 3D height? What gives my cylinder that 3D shape? That would be 12. Yeah. So I'm going to go 7 squared, which is 49. And then I'm going to take that 49 pi and multiply by 12. And remember, we're just going to leave pi in there. So first, what's 49 times 12? Because we want to have an exact answer and a rounded answer. So first, 49 times 12, 588. Is that what you guys all got? That's what I got. Cool. 588 pi. Okay. And then if we want to find out the rounded answer, we're going to take 588 and just hit times pi. What do you guys get? What's 588 times pi? And you're gonna have a long decimal. Let's say, let's round it to the nearest hundredth. So 2 places after the decimal. Okay, Malia got 1847.26. Is that what you guys got? And in your calculator, you're just going 588 times pi. Mariam got that? What about the rest of you guys? Sarah got that. Okay, I'll take it. Good job. So 1847.26, and we're gonna say centimeters cubed. Questions on that? Who likes volume? It's not too bad, right? Who loves volume? Do, 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 do. Go volume. Go volume. Kind of like volume. I like that. Good. That's good. Now we're going to talk surface area. Okay. So surface area is when you take the area of each surface and add them all together. The total area outside of a 3D figure, it's the area of all of the faces added together. Stretching out my back. So please take a second and write those formulas down. Okay? Take a second and write all of those formulas down. And I gotta tell you, if like I'm looking at this formula and it's a little confusing to me, if that's confusing, don't worry about it. We're just gonna find area of all sides and add. That's kind of what you're doing. Finding the area of all the sides and then adding them together. So I'm going to go grab some delicious jelly beans that we have because that'll help Jen not lose focus. And yeah, please write these 3 formulas down in your notebook. So this first surface area, this is for a rectangular prism. This is for a triangular prism, and this is for a cylinder. So write that down, please. Hoo-wah. All right, do we write it down? Oh, my new messages won't string up. Sorry, guys. There we go. Fixed it. Good. Okay, now when you take a 3D figure and if you like unfold it, okay, it gets something called, do you guys remember what this is called down there? Any guys any guys know what this is called down here? What is that when you unfold a 3D figure? A 2D. Oh no, your screen froze. Yeah. Yeah, you can unfold a 3D figure to make a 2D figure. It's also called a net. So guys, kind of look at this top box here and look at the net. It's kind of interesting. If you would look up nets of 3D figures, I'll have to do that. I wonder if I could do that and like send them to you. That would be really cool. But anyway, they're kind of fun to cut out and fold and put together. They really are. So, yeah. This is a net. Woo. These are Sour Patch jelly beans. It's very sour. When you're sleepy, it really helps. Anybody addicted to jelly beans like I am? Maybe not. I don't know. They are good. Okay. So yeah, it's just kind of helpful knowing what they look like when they're unfolded. That's why if you have to find the surface area of this triangular prism, I would try and visualize the net. It's not too bad. There's going to be 2 triangles and then 3 rectangles. Thanks. Okay. The other ones, there's formulas for, but for that triangular prism, I would try and we'll do an example about that. Try and visualize it unfolded. Okay, so we want to find the surface area of this rectangular prism. So we're going to start by writing down the formula. Surface area equals 2 times the length times the width plus 2 times the height times the length plus 2 times the width times the height. Oh, Kira, those are so good. Okay, what number should we use as our length? And it matters just because we got to use the same number as your length every time. Okay? 12. Sure, let's use 12 as the length. So for every L, I'm going to replace that with 12. So 2 times 12. Don't have a width yet. 2 times height times 12 plus 2 times width times height. Good. Okay. What should I use as my width? 3. Yeah, I like that. I think that's a good width. And what should I use as my height? 6. Yep, I totally agree. Good job, guys. And then it's just a matter for Desmos. Or you can go ahead and just do the calculations. This one's not too bad. So what is 2 times 12 times 3? We got to do the multiplication first, and then we can add them. So that's 24 times 3. What does that get you guys? And please help me with these calculations because it's super easy to make a mistake. What do you guys think? What's 2 times 12 times 3? Or 24 times 3? Or you can multiply in any order. 6 times 12. Yeah, that's 72. Yeah. And then what about this one? 6 times 2 times 12. Or 12 times 12. Yep, that's 144. And let's make sure we're all doing these calculations. And then what about that last one? What's 2 times 3 times 6? Or 6 times 6? Everybody knows what 6 times 6 is. Yes, 36. Very good. Good job. Then we're going to add them together. We're going to go 72 plus 144 plus 36. What do you guys get? 252. Good job. And then we would label that units squared because it's an area, so it's all squared. Yeah, good stuff. Right. Yeah, and that's a good way to view it, Sam, is adding together the smaller ones first, Good job. Yeah, the cool thing about addition and multiplication is you can do it in any order. So it's very much commutative. Did anybody just type the whole thing into Desmos and get 252? There you go. That works. All right, let's talk about this one. Find the surface area of the following cylinder. So we're going to write the formula down. Surface area is equal to 2 times radius squared times pi plus, and I wrote that a little big. I gotta write it smaller. Okay, surface area equals 2 times radius squared times pi plus 2 radius pi times height. Cool. So what is my radius for this one that I would plug in? 7. Yup, very good. So everywhere there's a radius, I plug in 7. What's my height? What's my height of my cylinder there? 12. Good stuff. And then again, it's more order of operations. Now here we got to be a little more careful because we have pi. And we have to make sure, if you type all of this in a Desmos, it's going to get you a decimal. And that's fine if they want a rounded answer, but they're probably going to want a exact answer first. So we got to do our order of operations. So we got to do what's in the parentheses first. So 7 squared. What's 7 squared? 49, yeah. 2 times 7 is just 14, right? And then we're just multiplying. We're going to go 2 times 49. What's 2 times 49? What's 2 times 49? 98? Yup. And then what about 14 times 12? $168, yup. And now both of those have pi, so they are officially like terms. So I can go ahead and add them together. I'm going to go 98 plus 168. How many pi's do I have then? What am I left with for pi? $266? You guys agree? If we add 98 and 168, we get 266. Good stuff. So you would say 266 square centimeters. And then if we wanted an exact answer, yes, sir, that's right. If we wanted an exact answer, we would go to Desmos and type in 266 pi. And that gives us 835.66. Perfect. Any questions there? Questions? Or does that make sense? Super confusing. Remember, you can private message me too. So that works. Good. Melissa, how you doing? Aiden, Taylor, Declan, Corey, Henry, and my friend Sam. How is that going? Good. Aha, that's okay. No problemo. All right. So last question I have for you guys. Which one looks like it's set up the right way? So according to this one, this is the formula for a triangular prism. You take 2 times the area of the base plus the perimeter of the triangle times the length of the triangle. What do you mean the base is not counted? So like they don't have a base? Is it like an open cylinder? Oh, that's a good question. Well, then, do you have one of the bases? Both are not counted. Okay, so then it's almost like you're just taking the middle section. You know what I mean? So let's look at that formula. Okay. So according to this formula has 2 times the area of the circles. So I would say you would keep the surface area and subtract the circle part. Because then it's like you're finding it and then you're subtracting it out again, or just focus on this middle part. 2 times radius times pi times height. That's what I would do. Try it that way, because this part represents the circle. Oh, that's volume. I'm so sorry. That's surface area. Let's go back to the volume. Yeah. Huh. That's a good question. I would think you still do the same formula because it would still have that space in between. Oh, did you mean surface area or volume, Mariam? Okay. No problem. For surface area, I would do that. I would subtract. Excuse me. Woo! Sour jelly beans. You would subtract that part. So just do this part. 2 times pi times radius times height. Just do the middle part. Because the first part is for the circles, and the second part is for the middle. Okay? That's what you would do for the surface area. All right. So, what do you guys think? Let me get to my other page here. Which was the correct way to set it up? So it looks like the only difference is Oh, hi, Silver. Come up here, bud. My cat's looking nervous. The only difference is the 4 and the 1.5, and then the 4 and the 1.5 here. It's almost like they want to know which one's the height of my 3D figure and which one is the length of the triangle. Guys are saying second one. No, I'm sorry, not the height of the triangle. Yeah. Yep, so when you do the surface area for the triangular prism, you want to do the second one here. Okay, the second one, you want this part in the front. This is the triangle area, so that one has to be the height of the triangle. And then the second L has to be the 3D figure height. So it's definitely number 2. Cool. That's all I got for you lovely people today. Does anybody have any questions? Already? Well, if there are no questions, you are free to go. Remember, if you want to work